Hello everyone, this is Matthew Tucker. Welcome to another tutorial in the Bifrost Rigging Module series. In today's video, we'll be creating a custom spline module. Well, let's get started. First things first is we need to go into the Bifrost graph editor and create a new graph. Since we are making a new custom module today, we're going to be using the template module. And wherever we need to make a new module, we need to right-click it and make it editable so we can change whatever we need to inside the module. Since parenting is an important part of any module, let's make sure we have another module to parent this new module to. So I'm going to bring in the root, set that as our base module, connect the inputs, the outputs, connect our template module as well to the inputs and outputs, and take the outputs of the root module and connect it to the parents of the template module. Now with all that done, let's go ahead and generate a Bifrost rig. So then we can watch our viewer as we populate it with controls and joints. So now that we have everything hooked up, and we know we're making a spline module, I'm just going to use 2 pins, a start and an end point. So in order to create pins, I'm going to delete this port, select the template module, and add 2 pins. I'll name the first one base, and the first one end. Now I want to make sure all the scales are set to 1 in our pivot matrices. Now with that done, I want to plug the inputs back in, and we're ready to use these pins once we dive in. The first thing we need to do is navigate to the user setup area and start creating our joints and controls. So with the spline module, I want to use any number of joints and any number of controls in the middle of it. But we do know there will be a start joint or a start control and an end control. So let's define those now with the define control. And for the name of this, let's use the name of our module. As a prefix, we'll call it spline. And for the suffix, I want this to be the base control. So this is the base control. We'll tag this with spline and base. Now for our end control, I do the same thing by copying and hitting Control-C and Control-V and changing the base to end. So now we have our start and end controls. Now with those 2 created, let's go ahead and hook them up to the outputs of the user setup area. Take my base control and our end control. And let's go to our outliner and move our pins to another spot for when we generate our controls and joints. Let's move it Y up in space. All right. And our controls do exist, but the pins have not been hooked up to their pivot matrix. So let's do that now. We're going to go and create a find pin node and plug the pins output to the pin input. So the first one, remember we called that base. Let's plug that into the base control. There we go. And let's make this a little bit easier to see in our scene. Let's make squares are fun. Let's scale them up. And let's rotate them in X by 90 degrees. So they're Y up. Let's change the color to, let's make it green. It's a fun color. And let's do the same with the end control. Square. What scale did I use? Let's make this maybe 15. Now let's attach the end pin to the end control. There we go. That's 190. Now our controls are in the right spot. So since we already have a root module in our scene, but the controls aren't following along, let's hook those up now. I want to create a find parent node and hook the parent's output to this node. So going to use wildcard since there's only one control in the root, and the same with the joint. But we don't need to use the joint one for right now. We're just going to use the control for our base and our end. So now if I move this around, our controls are following along with the parent. So with our module, we want an undetermined amount of middle controls to control the spline. So we're going to do that using an iterate node. So I'm going to use iterate. And here, the max iteration will be the number of controls we want to generate. So let's start with just 2. Now, I'm going to use a define control node, but I'm going to put it inside this iterate node. So let's do a define control after jumping into our iterate node. And just like these nodes, we're going to change the names to spline. Go back. Spline. We want the name from above, from the top of our module. So I'll connect that to the inputs, jump back up, grab the name, and plug it into the iterate node. So now this has automatically been updated. Let's do the same thing with the parent control. Let's connect the output of the control that we have so far. Actually, let's make sure we update the name as well to reflect the number of the control. So in order to do that, I could plug the current index of our iterate node into the suffix, but it's going to give me an error because I'm trying to plug a int into a string, and it doesn't like that. So I'm going to disconnect that by holding Control-Alt-Shift and slicing that. So in order to convert that, I'm going to use a number to string. Plug the current int in here, and plug that string into this suffix. So now whatever number control it is added to the end of the suffix. Then finally, we need to set the pivot matrices for this control. So for the middle controls, I want them to be in between our base and end control and evenly spaced out. So in order to do that, I'm going to go up a layer and grab the base pin and plug it into the iterate and the end pin. And just to make it easier to remember, let's rename those ports by right-clicking and doing rename port to base and end. So now that those are in there, I'm going to use an interpolate transform matrix, which will take 2 matrices and allow me to blend between the 2 of them. So let's take our base and our end pivot and plug it into our pivot matrix. Now, in order to see what might be happening with these min controls, let's plug the output of them out here and plug it into the output of the setup area. So I'm getting an error. And that's because I have an iterate node that's making multiple controls in here. Right now, it's set to 2. But the output right now is just set to a regular object. I need to set this to an array so it outputs correctly. So I'm going to right-click on the control definition and set it to set port iteration target. So now, if you see, the port has changed symbols, and now it's an array, and it is accepted in here. So let's go back into our iterate node, and let's change the... Let's make this more obvious. Let's do, we'll just do circles, and we'll make them a little bit bigger. We'll change their color to red. Great. So we can see our control. Let's rotate it as well. We can see our control, but they're only at the base. That's because the fraction is set to 0. If I dial it all the way up, it's set to 1. But I want them to be evenly distributed. So what I'm going to do is take the inputs of the iterate and plug that into the fraction. So in order to do that, I'm going to use a divide node. And I'm going to divide the current iterative step out of our iterate node divided by the max iterations. And I'll plug that into the fraction. So nothing changed, but that's because I'm dividing an int by an int. And what we want is we want to output a float. So let's disconnect those wires and create a toFloat node. So this is going to take our ints, our integers, and turn them into floats. So now if I take our current index and divided it by over the max iterations and plug that in, we can now see both of our controls, and they're no longer sitting on top of each other. But with the current index set to 0 and the second one set to 1, I want them to actually be 1/3 and 2/3 in between the two of them. So I'm going to increase the max iterations just for this math by 1. So I could use an add node, take the max iterations, right click, create another value, set this to 1, plug that into the two floats. But that's a little complicated. There's a way to do it with just one node called increment. If I take the max iterations, plug that into the value node, plug the output of that into the float, I get the same value with one less node. So that is now going from a 2 to a 3. And I could change that to anything. Any higher number than 1. Could be 2, 10, but I just need to increment it by 1. So they're still not in the right place though, because my very first current index is 0. And I'm doing 0 divided by 3, and that's not giving me the value I want. So I want to increment the current index as well. So plug that into there. And now we have our mid controls evenly distributed between our base and end control. Now let's look at these controls. Right now it's spline underscore template 1. I actually want them to have another suffix at the end. So I'm going to build a string. So with the build string, I want this to, let's create a value. This value would be underscore mid underscore. That'll be the first value. And plug our number to strings into the build string. And now that those are joined together, I want to plug that into the suffix. Now if I look at it, there we go. Now we got spline underscore template underscore mid underscore 1. So it's pretty easy and convenient to build strings up and dynamically have your controls or joints named on the fly. Now, before we leave the setup area, let's create joints. So just like with the controls, I'm going to use another iterate node to create any number of joints I want in between the base and the end. I'm just going to Control C and Control V that other iterate node. Now we don't need the, actually we will need the joint parent. And we'll need these matrices and yeah, this all looks great. So since we have everything in here already, we're actually going to use a define joint node instead. So let's plug the pivot matrix in, plug in the suffix, prefix name is spline, plug the name in. Let's get rid of this outliner to give ourselves a little bit more space. Let's delete that control definition and plug in the joint definition. We don't need this control definition, and yeah, there we go. So now if I plug this into the joint definitions, we're going to get the same error because I didn't set the output to set port iterate target. Now with that done, we have 2 joints made. Let's make some more joints. Let's make 10, 15. Yeah, that's a good number. But none of them are parented to each other, and we need to make sure they're actually touching the base and end controls. So first things of note, we need to set up or hook up the base control to our defined joint. Now, all our joints are connected, but they are all children of the root. So what I want to do is I want to take this iterate node, and every time a new joint is made, that is the next joint's parent. In order to do that, on the output, I'm going to right-click this and set port state to the parent control. So now, every time a joint is made, that will be the new parent joint. Pretty handy. And now let's fix the joint's not touching the right area. So it's just a little bit of math. Just gotta delete this increment node. It will automatically remake that connection. And let's, I think, decrement this by, so I could increment it by -1. But there's also another node called decrement, which does the same thing, which might be a little easier if someone's diving in and trying to figure out what's happening. It's like, why am I incrementing by a negative number? So I'll just use decrement. So it's a little bit easier when someone else comes in here and uses this. So now our joints are made, our controls are made. It is all dynamic. Now with that done, let's clean up the scene and start promoting some parameters so that at the very top of the graph, if I select this module, which I'm going to call this spline, no, test, just call it test. At the very top of this, when someone selects a module, they will have the parameters to change the number of joints and the number of mid controls right here. So going back to our user setup, let's first clean this up. I'm going to put the pins together, hit Control G. This will be called define pins. We don't need the pin connection being put in here twice. So if I go in here, hit L to reorganize, use just one pin connection, delete that port, rename this to base pivot matrix, rename this to end pivot matrix. We got our pins. Let's put our controls together. Let's rename this to mid define mid controls. Let's group these together. Selecting them, hitting Control G. Define controls. Same thing as before. Let's get rid of redundant ports. Just use one name port. Delete and delete. All right, and I want to put the pivots together. So I'm going to right-click this and move it up. That way, a little bit easier on the eyes. Let's rename these to base control definition. Let's reorganize this. Let's have the, no, that makes sense. And let's do mid control definition and end control definition. Great. All right, now this is the define joints. And if something's ever been renamed, but you're curious what the node is, you can click it and it'll tell you over here, like the find parent, even though this is called find parent 1. Or you can click T on your keyboard, and it'll give the name of the node above the node. So pretty handy. Got to find parents, group these together, find parents. Probably start fast forwarding through this part. Now with this organized, let's promote some parameters. So just for an example, go into the joints, and what we want to promote is max iterations to the very top. So in order to do that, I'm going to create a new input tab, plug in the max iterations, and rename this to joint count. Call this the joint count input. Now with that made, let's go up one module, and we can see that new parameter has been promoted up to the user setup. Now I'm going to plug that into the user setups, and now we can see that parameter is up at the very top of our Bifrost graph. So now if I go in here and start changing joint counts, that is now controllable at the very top of the module. Now let's move to the transformation part of the graph, the user animation section. Let's get rid of this area with all the helpful hints and get to work. So let's grab what we need out of the animation inputs. First will be the controls, find transforms. So we have a base control. I'll go by, let's do tags. Base control, end control, and since we might have multiple mid controls, let's do find transforms with an S. Plug that in and by a tag mid. All right, and just to double check that all the controls have been grabbed, let's create a transform scope just to visualize the controls existing in the animation area. So let's take all these transforms and convert them into matrices by using an access transform matrices node 3 times. Right. There we go. And to give myself a little bit more space, well, let's first visualize these. Boom. Put this one here, and also plug this one into the fan array. We don't see it because we need to hit the debug node and make sure the debug option is set on the top of our module. So let's hit that debug. There we go. We don't need to see any of the module's actual outputs just yet. We just want to see this specific thing. And let's dial the scale up. Great. So I only see our end control and our base control. Let's make sure I'm actually finding my mid controls. So I could go back to user setup, but let's first see what data we have coming in. So I'm going to right click on a connection and do open in data browser. So I'm looking at the controls, we've got our tags. Looks like we're actually missing some controls. Oh, no, I'm just missing tags. So now that I know that, I'll go back to the user setup, go to our define controls, our define mid controls, select this. Yep, I forgot to give it the mid tag. Now that's done, you can see now that transform scope has found the mid controls. Now that we're accessing our controls in the animation area, let's get rid of this outliner. Let's make a spline that runs through these controls. So go back to the user animation. Let's get rid of our little watch point. And we'll keep the transform scope around, but we don't need it just yet. So in order to build the spline, I'm going to create a resample matrix chain. So this accepts transforms, but I need to make an array of our controls so far. So in order to do that, I'm going to tab and build array, plug in our base control. Oop, I don't want to grab the pivot matrix. I want the world matrix of all of our different controls. Just to double check that that built correctly. Yep, built the correct array. Let's plug that into the resample matrix chain. So in order to visualize what this is doing, let's plug this into the transform scope. There we go. It has created a spline with a variable number of transforms. So I could increase this if I wanted to, 19, decrease it, set this to 10 for now. So one thing you might note is if I go and compare our resample matrix chain to our controls, by plugging the controls into the array, they actually have different orientations. And that's not ideal for us. We want this to have the same orientation as our controls. Now, in order to do that, we're going to have to change the resample matrix chain. So let's do that now. Now let's go and change this resample matrix chain. In order to do that, it's got this little symbol, so I need to right-click it and make it editable. And let's start figuring out where the orientation is being changed in here. So I'm going to take this transform scope, hit Control X to cut it, and paste it in here. Start tracing through the graph where this is changing. So it's changing sometime before this node. Let's dive into, this is just accepting the transform, so it's not going to be changing in here. So it must be in the resample decomposed matrices. Let's dive in here. And it looks like preprocessed data has some up vector nodes and a forward axis. We probably want to change these because what it's doing is it's processing the transforms, which are all live. And we want to instead give it our own vector and our own forward axis just to make sure we can define specifically what orientation this spline should have. Let's go in here. Looks like this is accepting orientation positions of the input transforms. And it looks like it's automatically calculating that. Whereas what I'd like to do is to manually figure that out. So in order to do that, let's take the forward axis and plug that into the input field. Take that to the very top of our graph by connecting it to the input of each layer of the graph. Great. Now the import axis, I'm going to right click it and do create value node. And now I can actually manually change the forward axis. Right now it's set to X. Let's create another transform scope and watch this thing change live. So right now it's set to X. Our controls are oriented Y up. Let's set that to Y. Perfect. But we want the X to be our secondary axis. So let's change that next. Let's dive back into the resample matrix chain, process data, quaternion up vector. So it looks like this up vector is automatically being picked either Y or X, depending on if the up vector are the forward axis is Y. Let's just manually set that ourselves. So I'm going to take this rotate quaternion. We'll steal this delete all this stuff. There we go. Plug that back into the up vector since I accidentally deleted that. Forward axis hooked up. There we go. And let's take our vector and march it back up the graph. So let's rename this to up vector. Now I'll do the same. Plug this back in. I could have just changed it in the node itself and it would have been just fine, but I just wanted to make it a little bit more discoverable for the future. I'll probably plug this in at the very top of the graph so we can manually fix this. Now let's right click this, set the value node, and we wanted X to be going sideways to match this. I think that would be 1. Oh, be -1. There we go. Now our spline is faced the right direction. So as I'm moving our control, spline is aimed correctly and its rest orientation is the same as our controls, which is perfect. Because if I now take this and plug the output of that into our joints are now moved along. Looks like something's broken at the end here, so let's fix that next. All right, so I think the reason why the joint chain is broken now, why we're getting this little area going back to the root, is that our resample chain is 10, but if I go back to the very top of the graph, I have a joint count of 15. So let's actually plug that joint count into our user animation. So in here, I'm going to go in here and I'm going to find all the transforms, or all of our joints. So let's do a find all transforms, plug this in, plug it into the joints, and we just want to grab all of them. So this grabs all the joints of this module, and I'm just curious how many joints there are. So in order to do that, I'm going to do a array size. And this will allow me to plug an array, and it will count how many entries are in that array and output the total integer. So I'll take that, plug that into there, and there we go. Now we got a spline, moving along with controls. I think it even scales. All right, this is exactly what we want. This is perfect. Now, it's not ideal for the base to be moving around, the mid joints aren't. So let's have the mid controls now follow the base and end. So in order to get our mid controls to follow along with our base and end, we're going to use an iterate node. We're going to insert it right before the resample chain. So let's give ourselves a little bit more space. Let's also make this less distracting. Let's change the transform scope to wire. There we go. It's a little less distracting. All right, so right in between, let's add an iterate node. Now we know we want the base world matrix and the end world matrix. Plug those in and rename these. And finally, the world matrix of our mid controls. And we will only want this to iterate over the number of mid controls we have. So let's do another array size node. It's getting a little cramped in this area. So let's put this back. There we go. Okay. Now that we're in here, let's use the interpolate transform matrix And just like we interpolated the joints and controls in the beginning, we're going to do the same thing. Actually, we'll steal the math from those so I don't recreate it by hand. Let's go into the define controls, define mid controls. Let's just take all of this, hit Control C, hit Control V. Boom, that is so much faster. So let's plug in the output matrix to the bottom of the divide and the current. That's plugged into the float. And let's just output this for now. Set the port iteration target to true. Let's steal this transform scope just to make sure we can see our progress in this iterate node. Big again. All right. So what I forgot to do was plug in the base world matrix and the end world matrix. There we go. Perfect. Now with those hooked up, let's make sure they follow along. Perfect. The transforms are following along, but the controls aren't yet. That's just fine. So now with those, let's plug this iterate node into the build array where the mid controls were. Now we do that. Now our spline is following along. But if I was to check, they're not following our mid controls anymore. That's because we are just outputting the interpolated matrix between the base and the end matrix. And it's not incorporating any of the transformation of our mid controls. So for that would be the operator matrix. The operator matrix is just the output values of translate, rotate, and scale without also adding in any of the world position or that kind of stuff. So we just want to add that right after our interpolated matrices. So we're going to do that using a multiply matrix node. At the very top, we'll have the output of our interpolated matrices, and the operator will be plugged into the mult matrix. Actually, we don't want to multiply it by an array. We want to multiply it by the corresponding control. So in order to do that, I'm going to do get from array. And then as the iterate node marches through, I just want it to use the current mid control operator. Plug that in. Yeah, now that's no longer an array. It's just grabbing the right control for the right matrix. If I was to output that, there we go. Now our control is following along, and our base in control are driving the mid transforms. But our mid controls are not being updated. So let's plug in the output of this iterate into the output of the animation outputs. So I'm going to take the output of that iterate, plug it into the update matrices, but I just gave it 2 matrices without telling which controls to update. And thankfully, with the find controls or the find transforms node, it outputs the indices for those. So I want to use those, but it's on the other side of our graph. So a quick shortcut is you just left click, you don't hold down the key, but you just left click and then middle mouse scroll across the screen. You can make a connection across the graph if you don't see the connections. And there we go. Now our spline is driving our joints, and our base and end controller are driving our mid controls. Twist is interpolated down the spline. I think we're almost ready to publish, but before we do that, let's clean the scene up. All right, I've gone and simplified the animation graph. I'm just going to select everything, hit Shift B, give it a nice little backdrop, call this user animation. Let's change it to red, so it's a fun color. I've also gone through and set up the user setup area, make sure I gave all the inputs into input nodes so that those can go up the graph and into our test module. Everything's set up. So now I could even go in here and say if we wanted 5 mid controls. Not sure why you would want to do that. That's too many. Yeah, we got that working. We could up the joint count to, let's see if we just do 150. Is this going to break? Nope. Caused it to think a while, but now we have 150 joints working on a spline. That's really tanked performance. So let's turn off debug mode, turn off edit and profile mode. See if that speeds it up at all. I just had to go in my outliner, go to the Bifrost rig graph, and set the auto update to off because having 150 joints running across a spline and a module slowed things down, but now with the auto update off, we have our spline with 150 joints going for, say, a crazy caterpillar or snake. I don't know, something silly. Whee! But yeah, now that's all working in our module. Make this a more realistic number. Set this back to 2. Put auto update back on. But now with that all set up, let's publish this thing. So close, minimize these. Go up to Bifrost, optimize modules, make sure everything's optimized, make sure profile mode and edit mode is off, debug mode is off. Great. So let's publish this by right-clicking, hitting publish. Publish this as spline module, hit publish. Now we've published this module. So if I was to go in here and hit tab and do spline module, hook this up into the inputs. Let's call this new test. See if this exists. Not yet. Let's recreate this graph. Great. Now it's been recreated. Our new test is here. Let's move one pin here and the other pin here. Yeah, and there's our new spline. Published, remade already. Try parent all this kind of stuff, but we are all set. So thank you so much.